Okay, this question again has some fluff in it. All right. You don't need to know about how the volume is calculated, and the volumes of revolution is outside of the course of the Year 12 math methods. So you're just going to know that this equation exists, and you just need to crunch the numbers. It's calc assumed, so you will need to just use a calculator. That's all this is just an exercise and using the calculator. So how does this work? From the previous question, we saw that the graph did something like this and that the intersection was there, and we needed to find this area. Now, what we're trying to do is revolve it around and find the volume there, which is given by this equation. So our starting is 0 and we go to 3. So when we integrate this thing, all we need to do is say 0, 3, and right, it's all there. I'm going to get a little fancy and I'm just going to move the pi out the front because it is a constant. I can even do that with a, can't do that with a negative sign. And then I'm just going to write this down here and we will get to using the calculator. Bit of lag there. All right. And then I've just slightly run out of space. dx. Cool. Let's use the calculator here. So we've got, I guess, what we've done previously. Um, previously here, and I will just put in some brackets. Okay, and so now I can copy this all into the brackets, and then I can put our minus sign there, and then I can also put our pi value, whatever pi it may be. There we go. So all of this interactive calculation, we're going to integrate it. We're going to do a definite integral from 0 all the way to 3, but I realized I've forgotten one thing. I have forgotten to square this. There we go, now I can do it. So interactive calculation, definite. We're going to go from 0 to 3, and then we're going to hit that, and that gives us this number here, and that is our answer. So it's really just a calculator exercise. That's all this is.